In January of 11th grade, the focus group of 5 Kenilworth students met after school to work on a problem they had never seen before, the World Series problem. In the World Series, assuming 2 teams are equally matched, and the first team that wins 4 games wins the series. What is the probability that the World Series will be won in 4, in 5, in 6, and in 7 games?
When do we do like a...
We had worked with the students on a lot of different combinatorics problems and towers and pizza and extensions of those things. So we decided to see what was possible. Given all of the different ideas that they had built, we wanted to see if they could solve a particular probability problem without having been taught how to do it, without any formal rules or notation or anything being imposed. We just wanted to see what would happen.
Oh, man.
So in 4 games, would it be like 1/2 of a chance? Or would we have to write out with using all 7?
See, I think that it's the hardest to win it in 4 games.
4 games.
Definitely
Yeah,
hardest.
exactly. So why would
So that wouldn't be
the odds
1/2.
The odds of winning 1 game times the odds of winning 1 game times the odds of winning 1 game. That's times a half.
They did the problem in about an hour, and they did it correctly. And I've been studying the tape for about 2 years. There's a lot of mathematics in the tape, and I'm looking at not only what they did to solve the problem, but I'm trying to look for the origins of those ideas.
Remember, the odds get harder to win 2 in a row, like a coin flip.
Yeah, that's how you do it.
Mike worked on his own, using Pascal's triangle, while the other students worked together.
It would be like, say, with the probability of something winning would be like B, 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 B.
Yeah.
Any ones that had B, B, B.
Then that would be that number to that number. That's what I was thinking.
So we gotta do it like that.
But
Moving on to 5 games, Romina proposed writing out all combinations, using strings of A's and B's to represent the wins.
like 5 B's or 5
Yeah, I know, I'm
A's
just saying,
in
like,
there.
each time we'd look over, like, well, 5, well, we'll see how many, you know?
Of course, for a 4-game series, it's pretty easy. You either have 4 wins in a row for this team or 4 wins in a row for that team. And for a 5-game series, it was a little bit more complicated. And they realized that they got 8 different strings, but when they tried to figure out what the probability of that was, they knew it was 8 over something, and it was the over something part that they had a little trouble with.
They have 8 ways of winning, but it'd be over.
Wow. 8 over 1. No, well, how do
It'd
we
be
find
over
out?
the total possibilities of two colors and 5 things.
They seem to have the idea that probability is the number of favorable outcomes over the number of total outcomes, although they never said that, they never had that definition. But it was an intuitive type of thing that they seem to have been doing.
You know what I'm talking about or not?
Yeah, it's got to be over 2. The 4
Total
just
possibilities
4
again, A, B,
spaces.
yeah, 4 spaces.
Yeah, all right, makes sense.
That's
and then
what,
that would be 8 over
that's
2 to
4,
the 5th, you
8.
think?
That's 16,
And then 8 over 2 to the 5th.
I guess.
So then they got to a 6-game series. It was a little bit more difficult to list all the different possibilities for 6 games, but they did it. When they got to the 7-game series, they realized that that was going to be a lot to count.
See double in there? I can't even look at it.
Want to
Is it 7?
This is a...
I wrote up 10.
Encorp found out that his winning probabilities for 4, 5, 6, and 7 games added up to 1.
It is right. 40 out of 128. And the whole thing adds up to 1.
Is there a match with them?
They match.
Wait, 48 to 128?
Yeah, it works.
They looked at it in cases, 4-game, 5-game, 6-game, 7-game series. They got the probability of each one individually. They saw that they gave them a total of 1. They knew that that was what was supposed to happen. And they were ready to present their solution, all using representations that were basically retrieved from earlier investigations and maybe modified a little bit to fit this situation.
So basically what we did was that could be 2 possibilities, that could be 2 possibilities, that could be 2, and that could be 2. And that was like when we went back to the old days and it was like 2 to the end. And then 4. Now that's not too convincing because we just went through them, but we went through all the ones that were out of 5 with 4 A's. That's how we got that. I don't think we have a real concrete mathematical backing to that.
At this moment, Mike presented his approach. Mike used Pascal's triangle to explain his strategy.
I just found, like, the went 4 to 7, not 4 to 8.
Oh, yeah, I know. But I'm saying, I don't know.
So Michael notices in the triangle that on one of the diagonals, he finds the numbers 1, 4, 10, and 20. And the counts in each case The count for a 4-game series, the number of ways you can win a series in 4 games was 2, and the number of ways you could win it in 5 games was 8, and in 6 games was 20, and in 7 games was 40. So he's got 1, 4, 10, and 20 in this diagonal, and if you double them, he said that's 2, 8, 20, and 40. So there's obviously some connection, he said, but I don't know what it is yet. So they spend some time looking at that connection. I think initially it's just an interesting insight on Michael's part. He notices a pattern there. Noticing that connection spurred all kinds of activities over the next 3 sessions that allowed them to do some pretty sophisticated mathematics.
In fact, I wish someone would do it on the board on the right there. Write that addition statement using factorial notations.
All right. Minus x plus 2, exactly. You know how like intimidating this equation must be? Like if you just pick up a book and look at that?
You do very carefully check that arithmetic.
You think we're wrong?
It is, it's right there.
What do you think of these
Where is
paper?
it?
It's right above n over x.
There you go.
Yeah. All right.
Sure.
Yeah, I'm sure. You got anything else?